Good evening, everyone. My name is Amit. This is Gate Physics live sessions phase 2. Uh, we completed phase 1 from I think August to October. Now we're starting phase 2 in November, and we'll most likely go right up to uh, the exam date of GATE for physics, at least, because physics is usually conducted in the second week of the GATE. As you know, GATE is conducted over 2 weekends. So on the second weekend, physics is usually conducted. So our last session will be some up to that. So. Uh, Anyways, I'll wait for a few more minutes because sometimes people join a little bit late. So we will wait for a couple more minutes. It's good to see so many people. To be honest, it's very it's very healthy to see such turnout. Um, just to I'll reiterate these points again, but I'm just pointing it out at the start also. Just please stop me anywhere you feel that there's a doubt in your mind regarding the subject that we are talking about. Even if you feel that you do not want to ask in the class, so here is my email ID. I'm sharing it on the chat. You can email me. I usually reply within a week or so. Just hold on a second. People are trying to join. Yeah. So this is my email ID. I have a YouTube channel also where I upload the live sessions that we conduct here. So you can it's with the same name, the name that you say, Learn with Amit Bansal. Uh, all right. We'll begin now. I'll be sharing my screen. So let's do that. Just a minute. There is some technical problem on my side. I'm trying to fix it. Okay. Right. I hope you're able to see my screen. Please
Yes, sir.
respond. Yeah. Okay. So as I told earlier, this is the first week for GATE Physics live mentoring sessions. This is the phase 2. My name is Amit Bansal. I'll be providing video solutions. But before we go into that, I need to talk to you something about the exam pattern itself, because when you are the GATE exam is a couple of months away. So I just need to tell you some things straight away, which I think should be you should keep into account. Okay. So yeah. So as I told you, I'm a fourth year PhD at Center for Nanoscience and Engineering at ISC Bangalore. I'm working on gallium nitride devices. So gallium nitride is a semiconductor. You might know about it. It's a semiconductor. I'm working on that. I have been TA for multiple courses, and this is my second time for live gate sessions also. And as I told you, these are my contact details. Learn with Amit Bansal at gmail.com. This is my personal email ID. You can email me on this, and this is my institute email ID. So, but I'll prefer you email me on the letter ID. Okay. So now what we'll do now, I need to tell you something about the NPTEL itself. That what you must know, but I'm just for the sake of completion. I think it's important that we talk about it for now. So this is the NPTEL website. Are you able to see my screen? Yes.
Yes, sir.
Yeah, so this is the NPTEL website. You can see gate.nptel.ac.in. All the information that you require will be available here. So this is the live mentoring session which I talked to you about. Phase 1 has been completed. This is phase 2 is currently ongoing. So you go to physics, and these are the I strongly advise you just go through these topics which each scholar is going through. Right. Apart from that, we have syllabus mapping also. So what that means is that, let's say in physics, you want to know about electronics, and what particular topic of electronics you want to know about transistors. So now you can go, these are the specific NPTEL lectures, these are in-depth lectures. So if you have some doubt, like you want to understand some concept, I strongly advise you to go through them. A textbook will also help. If you have a textbook at your hand which you're comfortable with, go ahead. But usually these lectures cover complete in depth. Even for my preparation, I relied on NPTEL videos only. I did not read any textbook. My background is electrical engineering. I gave the exam in physics, and I prepared myself using just the NPTEL videos and nothing else. Right. Apart from that, we have video solutions. So you can see there are different like mechanical, instrumentation, chemistry, physics. We are trying to upload. We have at least uh, I don't know, around 200 questions ready to go. So there is some technical side we are trying to fix it, and we'll provide you as soon as possible. And of course, these are some practice tests. You can go through them, the mock tests and other things. If you have, if you in your coaching, if you have something, that's good enough. There is just there's just no need to be like you have to be bound to this. Yeah, finally, now this is the thing about that. Now this is the most important thing. I'm now currently sharing the syllabus for gate physics exam. This is the thing which you must have at your desk, on your wall, anywhere. This is the much more than preparation. This is the thing that is important. You must know which topics are asked. So this is from last year 2022. So check whether there are some changes in 2023 or not. You are going to write gate 2023. So please, and you do not now what so this is the complete topics, 9 topics and then subtopics under them. Now this is not the complete picture. For instance, I'll tell you my experience. I told you I'm a background from electrical engineering. I did not even touch this thermodynamics, statistical physics. I did not even read one single word of it, and I did not attempt any question. Similarly, I did not read a word of atomic and molecular physics. I did not attempt one question. Same goes for solid state physics. Apart from one specific thing like yeah, diffraction of structure determination and this optical properties and dielectric properties, apart from this I did not touch solid state physics. So out of 9 topics I skipped 3 topics because I was confident in classical mechanics, mathematical physics, EMT and quantum mechanics. And I know now, once you know the topics, the important thing is you must know the weightage also then. So how do you know the weightage? So the weightage you get to know. So on your screen, this is courtesy Career Endeavor. They have outlined from which topic how many questions are asked. So always start from the last. So you see, in let's say in the last 3 years, around, so this year 9 questions were asked from mathematical physics. Only 5 were asked in 2022. So you must know which is your strength and how many questions are asked. So for instance, electromagnetic theory, always around 9 to 10 questions are asked. Quantum mechanics, again 9 to 10 questions are asked. Electronics, around 5 questions are asked. So here only one was asked. So in 2021. Similarly, you must know which are your strengths, which are your weaknesses, and accordingly you should prepare. You don't have to prepare every topic. I know some people who are comfortable in every topic. If you are, very good. I was not comfortable in 3 topics. I prepared only 6 topics: mathematical physics, classical, EMT, quantum, and then nuclear and electronics, and obviously general aptitude. So this is if some people are comfortable with this, some people are not. It's not necessary to score high in this. If you are good, very good. It's easy to clear the cutoffs. But even if not, just on the basis of the core subjects, you can clear the exam very easily by emphasizing on what are your strengths and what are your weaknesses. So that's the important thing here. Right. And also you must take into account the cutoff. So for instance, what was the cutoff last year? Does anyone know for physics? You should know this.
26.
Very good. 26 point something. So it's 27. Right. This is just the cutoff. Right. But institutions like IITs, IISc and other institutions put a higher cutoff than this for calling you for interviews. So you must, cutoff is just for it. You will be gate qualified. Like if you want to go some private sector job or public sector job, you can say I have gate qualified. So that increase, that's a good point on the resume. But for PhD or MTech, education institutes require a higher cutoff. So for that, you must have an idea that what have been the cutoffs in the recent past. So on your screen you can see the cutoffs for the past last year. It's not been updated on this website, so you can see. So the highest it went was 37. This was an abnormally easy paper, very easy paper. That's why the cutoff went so high. Usually cutoff is like someone told me it's 26 point something. So usually you see cutoff will always lie around, you can say 28 plus minus 2. That's the difficulty that they set. Usually it's that, because thousands of people write gate exam, and this is the final number that comes out to be. So and accordingly you should attempt. So for instance, even if you score 40 in the exam, ISC, IITs and other institutes, you will easily get a call. So you don't have to target 60 and then you do 10 wrong questions. There's no point of that. You attempt few questions, but ensure that your accuracy is 90-95%. So that's up to you. You have to I cannot say how to write your paper. That's up to you. I was just sharing what were my experiences with the exam, that what I did. Okay. Now what I am going to do is that, so now before I start, last time I did also, I need to know something about you. Okay. So for instance, I need you to give me the following information. First of all, obviously your name, and then what is your educational background, like MSc physics or BTech or some masters other than for instance, some people do masters in, let's say, electrical engineering or mechanical engineering or instrumentation, right? So you must your name, your educational background, what are you currently studying, what is your last degree, and plus what is your purpose. Because some people write gate for job purpose, in PSUs require that, some people for masters, some people for PhD. The requirements are different, so I need to know how to cater my sessions, right? And finally, what are your expectations? What do you expect from this session? Do you just want my guidance, that I should just provide you that how to prepare, or concept, like I should clear the concepts, and most importantly doubt clearing, plus plus there is some like how you want to talk. So if you want to talk, you can join WhatsApp group. I have no role in that, I'm sorry. But what do you want from me? Do you want guidance from me, concept building, doubt clearing, or any other specific need that you have? So please tell me. I repeat, please tell me your name, your educational background, what is the purpose, what is your aim for clearing the gate exam, job, masters or PhD, and what is your expectation from the session. So I'll start. My name is Amit Bansal. I am a BTech in electrical engineering. I'm currently pursuing PhD, and my purpose here is to mentor these sessions. And my expectation from this session is that you guys ask a lot of questions and interact with me. So what I'll do is that no, we'll speak, Kavya. So we'll start from the list that I have. So first is 17 underscore Darshan. Darshan, please unmute yourself and introduce. Darshan. Okay. It's fine. Amit Roy.
Hello, sir.
Good evening, Amit. Yeah, Amit, go ahead.
Yes, okay. My name is Amit, and I just passed out my master's in physics, and I'm preparing for the GATE and CSI NET, and I uh, plan to do PhD.
Okay. And what is your expectation from this session? What do you want from me?
Actually, I don't know how to prepare, and I always tend to forget means what I study, or so I don't know how to actually set my routine or something.
Okay, fine. I'll make sure that I touch upon that. Okay, next, Anuj.
Yes. Am I audible, sir?
Yeah, go ahead.
Yeah. My name is Anuj Misra, sir. I am doing my integrated MSc Physics from NIT Surat, and my expectation from you is to guidance for GATE exam, and from GATE I will do my PhD from any institution like ISC or
Okay, okay,
IIT. Thank you, sir.
okay. Next is Chaudhry Kamruzaman. Please.
Sir, I am Chaudhry Kamruzaman. I have just completed my MSc in Physics from Bardwan University in this October this year,
Okay,
September, October this year, and I plan to do PhD That's why I was preparing for all the examinations like GATE, CS, and
Okay.
I want you to solve as many questions as you can in this session.
Okay. Next is CC Varghese. Please unmute yourself. And if you want to, if you people want to write, it's fine. For instance, Darshan wrote he's MSc Physics. Sandeep wrote he's pursuing MSc Physics from Jharkhand and want to crack for PSU. So if you want to write, go ahead. There's no compulsion that you have to speak. Yeah, CC Varghese, please go ahead.
Hello, sir. I am Sisi. I completed my master's last month. I wish to clear the exam and do PhD. Hello.
Yeah, and what do you need from me?
I found difficulty in problem solving to develop problem solving and for doubt
Okay. Okay.
clearance to have good understanding of the concepts.
Okay. Next, Gaurav. Gaurav Yadav. Okay, we'll skip Gaurav. Gaurav, if you can write, it would be good. Harish Pal. Yeah, Harish.
My name is Harish Pal. I've completed my bachelor's in physics
Mm-hmm.
to crack IIT JAM. So I just thought that the syllabus is mostly similar to GATE. So
Yeah.
just for concept building, I'm attending these lectures.
Okay. Okay. Good to have you. Ishwarya.
Hi, sir. Good evening. I'm Aishwarya. I have done my MSc in Inertial. Purpose is to get MTech,
Okay.
and and my expectations is I always have a confusion and special theory of relativity,
Okay. Good. We have many sessions of
and
that.
I hope you clear it.
Yeah, I'll try my
Thank you,
best. Kavya, in case you have not spoken. No, Kavya, go ahead. So Gaurav has spoken. Okay. Okay, Kavya is not there. Khalid. Am I audible?
Yes, sir.
Okay, so Naveen, go ahead.
Hello, I'm Naveen. I'm a bachelor's in physics. I'm looking forward to do an MSc program in IIT and IISc. I'm also writing a JAM exam.
Okay.
I've also applied for GATE, so I'd like to try both of them.
Okay. Okay, Naveen. We'll try to touch some. We'll try to keep it somewhat lower level because some bachelor people are also there. Kavya, you are speaking. Naveen, you can mute yourself. Kavya. Okay. Pandya Rajan.
Hello, sir. Can you hear me?
Yeah.
Yes, good evening, sir.
Good evening.
Sir, I'm Kavya Prakash Adrim. I completed MSc from VNIT this year.
Uh-huh.
Sir, I'm preparing for GATE for doing MTech. Sir, I just want to ask one thing. Sir,
I can't. I'm not able to hear you, Kavya Prakash. Please write. Please write. It's fine. It's fine. You can write. I don't know the problem is with my side or your side. Can you repeat?
hello, sir.
Yeah. Can you repeat?
Yes, sir. I want to ask one thing. So, can I do MTech in electronics or mechanical engineering? Can you hear me, sir?
Yeah. Can you write? I think there's some problem in my from my side.
Okay, sir. Okay,
Yes,
sir.
I'm sorry. I'm
All right.
really sorry. I'll try to fix it. You can write it because chat will be there. So Pandya Rajan. Oh, you have written. Sorry. You have written. Prateek. So nice to see you again, Prateek.
Good evening, sir.
Good evening.
I am pursuing MSc Physics from Kurukshetra Universities, and I am applying for GATE to pursue PhD further.
Okay. Okay. Priyanka.
Hello, sir. I'm Priyanka. I have passed out MSc this year, and I want to give GATE and CSIR NET exam to pursue my PhD.
Okay.
and my expectation from you is to solving some doubts and some problems.
Okay, good. Rajiv?
Good evening, sir.
Good evening.
My name is Rajesh Sakrani. I'm doing my MSc second year from Suban Jina University, Uttarakhand.
Okay.
I'm I want to do research in PhD in nuclear and particle physics.
Okay, very good. Very specific research topic. Good, you have some clarity. Right. Okay, Rituraj?
Good evening, sir. I am pursuing PhD from Triple IT Jabalpur, and I am preparing for like Bombay or Madras.
Okay. Okay. Yeah. Rupesh? If anyone of the people remaining want to write, you can go ahead. You don't have to. Just if you want to write, you can go ahead right now. Rupesh, if you can hear me. Yeah.
I'm Rupesh Kumar. Basically, I have completed my MSc from NIT Durgapur last year.
Uh-huh.
And hello.
Yeah. Go ahead. I'm listening. Go ahead.
I'm saying I have completed my MSc from NIT Durgapur last year, 2021.
Mm-hmm.
Now I'm preparing for CSIR Net and GATE.
Okay. Right. Sangram?
Hello, sir. Good morning. Good evening.
Good evening. It's morning somewhere, man. It's all right.
sorry, sir.
No, it's all right. Sangram?
My name is Sangram Senapati. I just completed my MSc this year, and from you, sir, I always face difficulty in understanding.
Okay, I'll try to break it down concepts. Santunath?
Hello, sir. Myself Santunath. I have completed my MSc Physics from IIT Roorkee in May 2022, and I will be. I am for using this GATE exam. I am want to pursue the PhD in glass physics, and from you, I want to solve some doubt and build some concept in physics.
Okay. Sandeep? Sandeep, if you were with us. Sayantan? Am I audible?
I'm Shan. Yes,
Yeah.
yes, sir.
Go ahead.
Good evening, sir. I'm Shantan Sharma. I have completed my MSc in Physics from University of Calcutta this year. Currently, I'm working as a project JRF, and I want to pursue PhD. So I'm giving GATE exam.
Okay.
Your electronics lectures were very helpful. So
yeah, thank you. You're welcome. Shivam?
Good evening, sir. Myself Shivam, and I had completed my MSc last year from Delhi University, and I will be giving this upcoming GATE examination for pursuing PhD. And my expectations is you should focus more on concept building as well as on problem solving approaches.
Okay. Siddhita? Oh wow, another nuclear physics. Very good, Siddhita. Swati? Swati? Okay. It's all right. Am I audible? Can someone
Yes,
please?
sir.
Okay. So what we have is we have a heavy majority of the crowd is MSc Physics. So those will be taken care of. That's what I'm focusing on, anyways. But there are, I think, a couple of people from bachelors who are JAM and GATE, both the things. So I'll take care of that. I'll bring it down to a little bit lower. Anyways, I start with very basic concepts. So, but I'll explicitly make sure this time. And for the JRF fellow, I think your concepts, we'll just brush up the concepts, so you are feel free to hang around for that. Okay, now since I have noted down many of the things. So first is that those people who are trying for heavy majority of you are going for PhD, or some are from masters. So and the exams you must know. You already know, I'm just clarifying it. First is the graduate studies organized by TIFR, that is happening in December, on December 13th, if I'm not wrong. So I think the forms have closed, but this is a good exam which people usually give as far as physics is concerned. So it's not there for, I think it's for physics and computer science. But if you are for physics, you must make sure, if not this year, then next year you should at least write the exam. Even if you don't want to go there, just write the exam. It's a very good practice. Second exam that we have will be the gate, on most likely on February 13th. So you must circle these dates in your calendar and focus and plan. So many people ask how guidance, how to prepare. You must know your exam dates. That's most important thing. You must know your syllabus, and you must know which, I told you, like I skipped three complete topics for gate when I wrote gate. And similarly I skipped those three topics for net JRF also. And the third exam that we have is jest. That will be happen sometime in I guess March second week or March first week. So you must also fill that form. Do not fail as far as physics is concerned. The final exam is the net JRF itself, but I don't know. I went through the website, but is there any news on net JRF on December? I did not see any news in December 2022.
No, sir.
So I don't know what's going on. So but you must just keep a tab, keep checking that. And why I'm saying that, because you must prepare accordingly. So if, let's say, if there are, for net JRF exam, let's say there are 5 months left, then there is time to build your concepts, like to brush up your, revise some concepts. And if you have not done some concepts, go to this concept and try to build them. If there is only 1 month left, like for instance this I told you, graduate studies for TIFR exam is December 13th. There is no time left to build new concepts. Forget about new concepts, just give mock tests. And at least 10 days before mock tests, 10 days before exam, you must give mock tests, one mock test a day. How you find mock test, I leave it to you. There are many, like for, you can purchase mock tests online. There's very many websites, I forget, Byju's, Testbook and whatnot, Grade Up. There are many websites which provide for a minimal cost, like 300 rupees you can give 10 tests, or 1000 rupees you can give 10 tests. If possible, purchase them. Gate has some mock test papers, NPTEL has some mock test papers. Just please practice those are very important things, because in the pressure situation, what happens is, even if you know some questions you'll do wrong, you can fix only that when you do the mock tests. Okay, and please don't practice while you're sitting in blankets. I know it's cold, but when you'll be going in the exam hall, there'll be no blankets, there'll be no ACs, there'll be no heaters. So it's good, while preparing you can sit in a blankets, heaters, whatnot. But when you're giving exam, you should be a hard table and hard chair. And if calculator is allowed, have a calculator, otherwise not. You should give it in whole integrity. No one is watching you. It's for your preparation. No one is there to tell you how to do it. Whether you're cheating or not, it's up to you. No one is going to correct you. Right. So and please just make sure there is a difference in, because you will be writing multiple exams, and many people told me for guidance, there is a difference between the levels and the questions that are asked in gate and JRF and jest. Jest is usually a higher level. Anuj, yes, NPTEL does have some mock test. If you go to the nptel.gate.ac.in, on the last tab, there's an option for some mock tests. So they'll be trying to float maybe some more, but you can just give the mock tests. Yeah, please go ahead and do that, and you can give them. I mean, mock test is a very good thing to give. It keeps you on your toes. It keeps you practicing. You know how to write a pen, fill the OMR sheets and whatnot. Right.
Sir,
yeah.
But on NPTEL website, NPTEL portal, basically I have seen that all are available.
Which are available?
Only for 3 or 4 branches. Basically, sir, mechanical engineering, civil engineering, and other 2.
Okay, ठीक है. I'll pass this information along, that upload physics mock test for physics. Okay.
So I'm
yes, sir.
But I didn't get the mock test for physics, and also course.
Sorry,
I didn't get it. All for engineering branches, so for engineering branches there is a course also for the GATE exam. But for physics, it is not there any course and mock test for the physics
Okay,
students.
I think because what we do is that because for engineering disciplines, the number of people writing exams are higher. They're in lakhs. I'll be honest. So what we are doing is that NPTEL is trying to build. See, when we test, we will give it because the feedback will be more. So that's why we started earlier also because for the video solutions they were started for other engineering disciplines also. So I'll try to see if I'll try to see that if they are if they can upload it by this by that time, but I'll just pass this along. I'll give this feedback. So you need I'm sorry, what live courses, I forget what was the thing. Mock test I wrote down.
Sir, and live course also that are going with progress of GATE exam, sir.
Okay.
I can see the civil engineering, electronics, in electrical engineering, and mechanical engineering. They are four only here.
Okay, ठीक है. I'll pass along this information. Right. So
Thank
what I
you,
was saying is that for different exams there is some different level required. Please make sure that the level of gate, the questions that are asked in gate are not the same as those in net. Right, so that's from my side. Now we'll go ahead and start the actual work. It's been 30 minutes. It's fine. I always last time also I some of you might feel like that, okay, it's too much 30 minutes, but it's important that I should clarify these in the start. And if you still feel I missed some point, I've written my email to you. Just write an email to me. I'll try to respond as soon as possible. I'll sharing my email again. So yeah, that's that. Yeah, so you can write on this email. Now we are going to start. Okay, so one more thing. So my approach is that so I'll be starting in every lecture, I'll be starting with some concepts. Like for this, for the first 3 weeks, for the first 3 sessions, we'll be talking about special theory of relativity, more or less. So I'll be talking about special theory of relativity. I'll introduce some concepts in this class, and then in the next class we'll first thing we do is we go through some concepts, then we solve the problems taking those concepts. And one thing which I do, see, I am bad at remembering stuff, so I don't remember the formulae. So what I do is that I have a very specific approach. I have just one single approach, so I apply that approach to every problem in special theory of relativity. I just have one approach, and just two formulae I have remembered, and rest all I just manage with just those two formulae. So because I'm bad at remembering, I confuse plus and minus sign. So and it's your approach, you may decide however you want to, but I'll tell you what my approach is, and then you are free to go however you may like. Right, and then we'll solve some problems, and then after we have solved the problems, again I'll summarize the problem and the concept that we have, so that the idea is, the point of repeating is that it gets ingrained in your mind. That's the whole point, that you understand. You just not understand, just gets, if I keep repeating myself, it gets burnt in your brain. That's the whole point. And so last time what I did too many questions. I did 4 or 5 questions. This time I'll slow down the pace, so I'll be doing 2 or maximum 3 questions, and I'll focus more on concepts, so that you can interrupt me. You should interrupt me if you have some doubts. Okay, so any comments, any questions before I start today's session? All right, very good. So I hope you're able to see my screen.
Yes, sir. Yes, sir.
Okay. So as I told you, this is GATE Physics Live Sessions hosted by NPTEL. This is week 1. Today is November 27, 2022. My name is Amit. Right. So this is the term, this is the topic that we are going to consider. The thing is special theory of relativity. Okay. Now one more thing, I'll for every topic I'll tell you how many marks, how many questions are asked. So on an average every year 2 questions are asked from special theory of relativity. Okay, 2 questions means 3 to 4 marks. One question is definitely of 2 marks, both can be of 2 marks, so 3 to 4 marks. And the best part about this topic is that there are only 2 formulae. I told you there are only 2 formulae. Excuse me. No, I do not plan to upload videos regarding other examinations. I don't know, not soon, at least maybe a year down the line, but not soon, sorry. Okay, where was I? Yeah. So 2 questions are asked, 3 to 4 marks. So let's just do that. So that it's clear in your heads that it's 3 to 4 marks at least, and there are only 2 formulae. So it's scoring. You just have 2 formulae. That's it. 4 marks are in your bags, and these questions are not lengthy. There is not much calculation involved usually. They're very simple. They're very just a square root is involved, max to max. Right. So now we'll go ahead in the concept. So as you can see, there are 3 terms here: special, theory, and relativity. We'll go through each these terms one by one. First is relativity. What are we relating? So we are relating space and time. Okay, space we denote, it's a three-dimensional space, x, y, and z. So x, y, and z is the coordinates, x coordinate, y coordinate, z coordinate. Usually we'll only work with one coordinate because at this level 3 coordinates becomes too much. So usually we'll have only x and time, right? So only x coordinate, rest 2 coordinates we'll leave blank or we won't even write, and semicolon is to denote that space has ended and now we write time. So this is a notation I'll use. So first 3 coordinates are space, semicolon, and then the value of time. So for instance, coordinate can be 1 0 0, and let's say time is 2 seconds. So arbitrary units. Okay, second is special. What is special about it? The word says special. So there is one more theory which is called general theory of relativity. However, in special we neglect gravity. In special theory of relativity we neglect gravity. This is a very important assumption. Einstein gave it, I think, more than a century ago. Right. The third term here is theory. So what is the theory actually about? So it's a special theory, means we're neglecting gravity, and it provides some relation between space and time. Now how do we achieve that relation? So these are the twin concepts that you need to keep in mind. No one's going to ask them, it's just for your understanding. So the thing is, first is laws of physics remain invariant. Invariant means they don't change, right? In inertial frames. We'll see each of these terms. Second is very simple to understand. Speed of light is same for all frames. Speed of light, whether you are sitting here or traveling in a car or traveling in a spaceship like the movie Interstellar, whatever you are doing, speed of light is same for every observer. That is 3 into 10 to the 8 meters per second. Right. So now I'll get to these 2 terms. Laws of physics. Which laws are we talking about here? So there are some laws in physics which are very fundamental. Like we are talking about those laws, and an example of those laws is conservation of momentum. Conservation of momentum, it says that total momentum of a system remains conserved unless acted upon by an external force. That is the complete statement. So momentum remains conserved. This is a basic law of physics, and this remains invariant. Means whether you are sitting here on your table and chair, or you are traveling in a car, or you are traveling in a spaceship, conservation of momentum will remain constant, will be observed. It will be there. It's not like that momentum is not conserved wherever you are sitting. Second important law of physics that remains invariant, means it is applicable, is conservation of charge. You must have heard this statement that the charge can neither be created nor be destroyed, right? So that is the thing. So whatever charge is there, whether when I'm sitting here in a car or in a spaceship, the charge that I'm going to measure, for instance, I'm measuring here at 5 coulombs sitting at my desk. You are traveling on your scooter and you will also measure 5 coulombs, and somebody in a spaceship will also measure 5 coulombs. So the charge will remain conserved, right? But these will remain conserved, not always, only inertial frames. What are inertial frames? You must have heard inertia, the term, the first law of motion, right? An object remains at rest and moving unless acted upon by an external force. This is the same thing. However, we are defining what do we mean by inertia. An inertial frame of reference is the one which has zero acceleration. I repeat, zero acceleration means either it would be at rest, means velocity is 0. What does at rest mean? At rest we mean v equal to 0, or some constant velocity. So it can be 2i cap plus 3j cap and so on, meters per second, right? It cannot be time dependent. So for instance, v equal to 3t I cap. This is not constant velocity, it's time dependent. So acceleration will come 3i cap, right? So this is not an inertial frame. This is not inertial. This is inertial. Constant velocity, this is very important. Usually in your questions, we always assume it's an inertial frame, but we'll see. For the first few problems, I'll repeat this point again and again, that we are talking about inertial frames. And the second postulate is that speed of light is constant, which is 3 into 10 to the power 8 meters per second. Right. So I talked about inertial frame earlier. Inertial frame, what do you know? Inertial frame with no acceleration. No acceleration. This is the definition of inertial frame. Now, what is an observer? Literally in English mean observer means something which observes. So when you are observer, you are observing something. Like for instance, right now you're watching your screen. So you are the observer and the object is the screen here. Right? So every frame can have an observer. For instance, this frame. On the left of the screens, you see a blue frame. So I told you x, y, and z, these are the Cartesian coordinates. Usually we call this frame as frame O or frame S. Let's call this frame S. This is frame S. And an observer here is sitting at the origin. I'm calling this observer O. So whatever is happening in this universe, this is this observer will keep telling us that. We'll see what can this observer observe. Can it observe invisible things, sound, light? What does it do? How does it observe? Second, you see this frame. Again, this is a constant velocity. We'll assume this is constant. So again, remember, no acceleration. I'm assuming no acceleration. This velocity is constant. Again, I'll assume Cartesian coordinates. Let's call this frame S prime. You see this notation. So moving frame we denote by S. Sorry, the frames at rest we denote by S. The moving frames we denote by this prime. So you see everything is primed, right? And it's moving at V at a constant velocity with respect to this frame. This is also inertial frame, I told you. And here the observer is sitting at O prime. Now I told you, what do these observers do? These observers observe an event. What is an event? Event is, like, let's say if someone's sitting here, P claps. So what will this observer say? Okay, so this P is sitting at, let's say, coordinates 3, 2, 0. X is 3, Y is 2, Z is 0. And I heard this sound at, let's say, 20 seconds. So rather than having 3 coordinates, observer O will say that P has 4 coordinates, 3, 2, 0 and 20. Okay. And let's say this O hears another clap, but from a different distance. So let's say this time it says 10, 5, 0. Let's say at 50 seconds. So again, this observer has heard 2 claps. First, it said that he said first clap P happened at 3, 2, 0 and 20 seconds. Second clap Q happened at 10, 5, 0, 50 seconds. Now the beautiful thing about it is that this is moving, right? But this can also hear the sound of these claps. However, we'll call this event P prime. I told you everything is primed in this universe, in this frame. This may not observe the same coordinates. Let's say I'm just saying anything. This is x prime, xp prime, and let's say other coordinates do not change. Other coordinates will not change because only when moving in x, and time will also change, tp prime. And the second clap, this O prime will hear second clap at xq prime, 5, 0, tq prime. So that is what an observer is doing. So you see, actually only one event happened. The first clap happened at P. O says it happened at P. Here the different observer saying it's happened at P prime. This is the relative. So we have to link how is P related to this P prime. That is so P, Q or P prime and Q prime are the events. Event can be a clap, event can be anything. Anything that happens in this universe is an event. You're sleeping, it's an event. You wake up, is an event. Your phone rings, is an event. Everything and anything is an event. Now I told you, P and P prime are essentially the same. We know that this is the same event that's happening, right? You are watching. 28 people are in this session right now. Each of you is viewing from their own viewpoint, correct? But there's only one event happening. There's only one me speaking at one point of time. So all these events have to be identical, right? That's what we mean. And we denote it by something called space-time interval. You know, if let's say I want to do the distance between OP. Distance between OP would be 3 minus 0 square plus 2 minus 0 square plus 0 minus 0 square. I'm doing nothing but x2 minus x1, y2 minus y1, z2 minus z1, square root of this. This is the distance OP here, right? A similar concept in special theory of relativity exists. We call this as space-time interval. It's usually denoted by delta s. You can think it just as the distance. Okay. Now this is the most important. Like we saw in the previous slide, we saw there were two concepts. That law of physics remain invariant, and the other was speed of light remains constant. So both of them are condensed in this. It says that space-time interval remains invariant across different initial frames. So we have first frame here s, second frame here s prime. So if we calculate delta s in first frame, and if we calculate delta s prime in second frame, both of them should be equal. We have squared them because usually they are distances. They're distances, so we usually denote in this way, right? And this is the formula for that. Remember, this is, I told you there are only 2 or 3 formula in this whole special theory of relativity. So this is the formula. Delta s square will be c speed of light. What is delta t? Delta is time between these two events. So here it is t2. T2 is 50 here. Note that. So t2 is 50. This. What is t1? So I'm writing that. So this will be 50 minus t1 is 20. This will be 30. What is x2 minus x1? Means second event minus first event. What is the second event? Second event here is this q. x2 is 10. So this will be 10. x1 is 3. So this will be 7. Similarly, y2 minus y1 will be 5 minus 2 will be equal to 3. And 0 minus 0, this will be equal to 0. And you can put in this formula and you can calculate the value. That's not the point here. That's simple arithmetic. The whole point is that space-time interval is calculated using this formula, and space-time remains invariant. So whatever the value of delta s you obtain here will be the same for delta s prime. You know that we don't know xp, xq, tp, tq, right? We can denote that using this equation, right? If you plug in all the values here, like delta t prime you can put, so I'll write delta t prime would be tq prime minus tp prime. Similarly, delta x prime would be xq prime minus xp prime. This will be a very complex equation. If we put in, we can solve it. There are some codes and some people have done it. You don't have to go through that. The thing is, this is the whole point of this exercise. Special theory of relativity, this is the starting point as far as, for the competitive exams that we're talking about. This is the thing that you need to remember. And the fourth thing that we note is transformation. We'll come to this. First, let's just focus on space-time interval for now. Okay, right. So I have explained the concept here. I'll just go through the concept once again. So what we talked about is that special theory of relativity. We ignore the gravity. We relate space that is xyz and time across two different frames. So the first frame is s, second is s prime, and this is how they are related. Delta s square equal to delta s prime square, where delta s can be calculated like this. Similarly, if you need, delta s prime square would be c delta t prime squared minus delta x prime square minus delta y prime square minus delta z prime square. Don't get scared. I'll solve a problem and you'll see how simple this is. So till now, do you have any doubts in the concept itself? We'll go through a problem just based on space-time interval. If you have any doubts, because this is important, I'll be always invoking this inertial frame. Okay, just hold on a second. Shivam, go ahead.
Sir, is it by definition of space-time interval that we define it as a difference of a temporal coordinate, or it will be another way around?
No, the thing is, it depends on notation. It's a good question. So the thing is, sometimes in some places I have written delta x square minus delta plus delta y square plus delta z square minus c delta t square. So it's not always like this. The thing is, there are different ways of denoting it. It's a point of nomenclature and nothing else. But the thing is, that one thing that is for certain is that these two have to be subtracted. Okay, these two have to be subtracted. Okay, actually,
Understood, sir. Understood.
there is a problem here. Actually, this whole square comes here. Otherwise, that dimensions will not be balanced. Yeah. So you can do. So we'll see. Just exactly this thing we'll see here. Yeah. Any other comments, questions? Okay. So just based on this information that we talk about inertial frames, observers, events, and this is the soul of the special theory of relativity. So what I'll do is that I'll now solve a problem from GATE Physics 2021. This is a very recent paper and very simple problem. So I'll first read the question and just stay with me here. So there are two observers, O and O prime, and both of them observe two events P and Q. Just like in a previous problem, there were two frames, O and O prime, and both of them are observing two events P and Q. And they have a relative speed of 0.5 c. Remember, we had here V. So this V is given 0.5 c. And the coordinates are given accordingly, and we are required to find the length of space-time interval. So again, we are required to find delta S as measured by O prime. So we need to find delta S prime. So this is what we need to know, right? Delta S prime, which is nothing but they are denoting it as L. So you see they put a mod here. The reason a mod has been put here because what you talked about, that it might come negative, and then the square root of a negative is imaginary, right? So to bypass that, a mod has been put here. That's why they did good here, whoever wrote this question, right? So this is the problem that was given. Instead of words, I put it in a pictographic manner. So two frames were given, O and O prime, right? We were given that O prime is moving with a constant velocity. Note, it was given it is a constant velocity. Constant velocity means this is also inertial frame. Had it been moving with non-constant velocity, this was not an inertial frame, and all the theory, special theory of relativity, whatever we are talking about here, will not apply. Okay, so we are given V equal to 0.5 c, and we are given two events. The first event is P, written in green. Similarly, the same event P will happen here, but its name is different because O prime says this event is P prime. We don't know the coordinates, but we know the coordinates of P are given here, right? And the second event is blue, which is denoted by Q here. Again, the coordinates are given as measured by O, the first observer. Again, we don't know. We know the same event will happen here also, Q prime, but again, we don't know the coordinates, and we are required to find out the space-time interval of O prime, this observer. That is what we know by formula delta S prime, or as the question asks, delta L. Now, let's do this now. So we know delta S prime whole square equal to C delta T prime whole square minus delta X prime whole square minus delta Y prime whole square minus delta Z prime whole square. What is delta T prime? It would be TQ prime minus TP prime. Similarly, whole square here, minus, so it will be XQ prime minus XP prime whole square, and so on. We don't know any of these. We don't know the coordinates here. We know none of the coordinates here. All the four coordinates are missing. We cannot solve using this approach. But we know, I told you, what is the soul of special theory of relativity? That space-time interval remains invariant across the inertial frames. So both of them are inertial frames. So if we find delta S square, that will be same as delta S prime square. And we can find delta S square. Why? Because the coordinates are given. So let's simply find delta S square, which will be ultimately we'll find delta S prime square. So what I'll do, I'll simply find delta S squared. So delta S square would be, again I'll use the same formula, delta C delta T whole square minus delta X square minus delta Y square minus delta Z square. Again, the time component squared minus the space component, right? So the value of C, I think we are asked to use, question says speed of light C can be taken as unity. This is you will see this many times, right? Because it simplifies the problems. The value of C is not unity, it just simplifies it. So let's say it to be 1. So delta T will become now then TQ minus TP whole square. Delta X will become XQ minus XP whole square. Delta Y will become YQ minus YP whole squared, and this will become simply ZQ minus ZP whole squared. What is the value of TQ? Is 5. It's nothing but I'm just substituting the values. Minus 3 squared, you see this is 3. XQ minus XP, XQ is 5, XP is 5. 5 minus 5 whole squared minus YQ. YQ is 1, YP is 3, 1 minus 3 whole square minus zq is 3 minus 5, 3 minus 5 whole square. This will come out to be 2 square minus 0 square minus 2 square minus 2 square. So this will be 4 minus 4 minus 4. This will come out to be minus 4, right? And we know delta s square is nothing but delta s prime square. So I can write delta s prime square equal to delta s square equal to minus 4. This implies delta s prime will be equal to, actually it will be 2 iota. But as I told you, sometimes there are different nomenclatures. Some places that the space component comes first, and it doesn't matter because we are required to find the magnitude of this. So I can write L equal to magnitude of s prime. Magnitude of 2 iota will be nothing but 2. This was the problem, numerical answer type problem, and the value of answer is 2. Right. One more thing, we solved this problem. Yeah, first I'll talk a bit later. So we solved a very simple problem based on just this. This is just a one single formula that we used here. That's this just, and the concept that the space-time interval across initial frames will remain intact. It will not change. That's the principle that we used here. So if you have any doubts regarding this, please ask. This is a very straightforward formula, very straightforward concept. I'll pause for a minute here and then we'll go ahead further. Okay, how did I know that it's negative? This is not the first time I'm solving this question. See, before I come to the class, I solved these questions myself. Even I deliberately took it to be negative. I deliberately put it that iota comes so that I can tell you that if iota comes, you don't get confused in the exam. It's all right. Even if iota comes, we are required the magnitude, and that will come out to be 2. I did not know it will come out to be negative though. I solved it before. I saw that there are two formulae. Sometimes space comes first, sometimes time comes first. For this question, I deliberately wrote this formula so that I can explain even if iota comes, you'll be able to solve the question, which is the idea here, to let you know how to approach these problems. Right, example of space-time interval. Okay, I'll again, someone asked, it's important, this is the very first thing that we should know. Let me go ahead and write this somewhere here. Yeah, okay. Forget about this concept. We'll go to some 11th 12th class vectors. Distance between 2 points. This is point P. Let's say its coordinate is 0 0 0. This is origin. This is Q, and let's say its coordinate is 2 2 and 1. And I need to find the distance between these 2 points. This is very simple formula, you know. PQ is square root of, or I'll write this, PQ whole square will be equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. I hope this is clear to everyone, right? This is just the formula that I am writing. This term that you see, this is called space interval. This is literally the interval means gap. Space here means we are operating in Cartesian coordinates, so we are operating in physical regime. That's why the term space here, x, y, z. Space interval means any gap between 2 points in the Cartesian coordinates, we call it space interval. Okay, let's do one more thing. P and Q. Let's say something happens at 10 seconds. And here something else happens at 20 seconds. I'll ask what is the gap between these two, right? What is the gap between these two? So I'll write T, time gap, equal to TQ minus TP equal to 10 squared, right? Sorry, equal to 10 seconds. Again, there are two things: space gap, which is denoted by this term PQ here, the distance, the physical distance. Second thing is the time gap, which is denoted by the difference between the times. Now, what this special theory of relativity, it says that space and time are not different. Just like when in the smaller classes, and I think up to 8th standard, 10th standard, we knew that there are only two coordinates, x coordinate and y coordinate. Suddenly we come in 11th and 12th and teachers told us there is a third coordinate also, x, y and z. Now when you come to STR, there is a fourth coordinate, x, y, z. Note semicolon t. Why I'm writing semicolon? To distinguish that this is not space, this is time. And this whole thing is we called space-time. I'll denote it this way. Sorry. Up until 5th standard, this was our world, x-axis. That's all we knew. In 8th to 10th standard, teachers told, no, this is incomplete picture. There's a second world also. Y is also there. In 11th, 12th, teachers told us, sorry, there's one more dimension called z, which is like this. And then we were told that this is the complete picture. No, this is not the complete picture. There's behind the scenes. This is the origin. Behind the scenes, there's some clock ticking. Time is there. For STR, Einstein said that you can treat time just as another coordinate. Time is another coordinate, and hence this convoluted thing, space plus time, this is what we called space-time. So time would be x, y, z coordinates. This is denoted by t, and space-time will be denoted by x, y, z, t. Going back now, we can measure distance, physical distance between 2 points, pq. We can also measure the time between these 2 points, right? And we can relate, and now we need to time in the space-time interval, what is the distance? What is the difference? What is the gap between them? Hence, this term was evolved, space-time interval. And its formula used to be c delta t squared. Note that, just like delta s squared equal to, and then minus pq squared, the physical distance. That's what we did there. Time, okay, how should I say this? Time is not exactly, it's not a coordinate in the physicals, it's not a coordinate in terms of like we Cartesian coordinate terms or rectilinear system terms. It's not. What I'm telling you is that time is a thing for every event. Up until now, we were learning that every event has a coordinate, 0, 0, 0, 2, 2, 1, x, y, z. Apart from that, there is another thing we should consider, that's time. So in that sense, it's a coordinate that in order to completely define an entity, you need the x, y and z positions plus at what time. That's what special theory of relativity is about. It says that just the position is not sufficient. You must also know the time, at what time who was where. That's the whole point of special theory of relativity. And in order to denote that entity, that if we also combine, if we make time like this, if we denote now every event, everything in this new universe as this, then we need a new entity. Like distance, we know the gap between these two entities is this. In time, in pure time world, the distance between two entities is this. What is the difference? What is the difference between the distance between the 2 points in this new universe, space-time universe? It's this. It's denoted by this. So it's for our sake, in order to understand, to mathematically interpret it. Because see, anyways, what we say, mass, gravity and all, these are the things which humans have evolved to understand the nature around us. Similarly, space-time interval is something which humans have evolved just by looking at the distance, that how we used to measure the distance. Just by looking at that, we evolved this space-time interval thing. For theoretical, for let's say for solving problems, or solving on not just problems for competitive exams, even for like when we are traveling at very high, for instance, there's a large hadron collider in Europe, CERN, right? There they accelerate the particles to very high velocity, very near to the speed of light. There they need these calculations. So it's not just it's theoretical, it's in books, it's real, it has practical implications. And in order to denote something which is close to distance in our physical world, we need a new entity to denote that, to denote the distance between. In space-time world, the distance is denoted by this space-time interval. So what I can say is that, like in 8th class on in aptitude terms, what we write, I'll write as this. So what is distance to physical world is this space-time interval is to special theory of relativity. That's in 4 words. If I have to summarize, this is how I'll do that. This is what you need to take with you, and you just need to that the formula that we know, that's there because we are here to solve the problems. Okay, I can't get past that. So delta S will be, or delta S square would be C delta T square minus that delta X square minus delta Y square minus delta Z square, where this distance between 2 points P and Q, where P is denoted by x1 y1 z1 semicolon, remember semicolon t1, and x2 y2 z2 semicolon t2. That's how these operate. So if I were to find the distance, so the distance here would be delta x square plus delta y square plus delta z squared pq whole square. This would be this. Oh, when did screen get stuck? Am I audible? Okay, ठीक है. So that's that. Yeah, if you have we are running a bit over time, so what I'll do is that I'll wrap up here. I'll again, don't worry, in the next class again I'll revisit the same concept, space time, because this is important. This is the whole special theory of relativity is based exclusively on this space-time interval concept. So I'll again spend time in the next class on this, and then we'll go ahead and we'll solve some more problems. So yeah, so if you have any doubts, you can go ahead. Any pressing doubts that you might have. All right, if not, you can email me if you want, if you feel that you have some specific question on, if you can email me. And anyways, this lecture I'll upload, this session I'll upload on YouTube with the same name. So not to, maybe today I'll find some time, so you can go through that if you need a follow-up, and you can always ask questions in the next class, and write to me if you have some questions. Some people do ask questions and I try to solve them. I reply to them using the email if I find time. Okay, thank you everyone, stay safe, good night. Thank you for joining, it was a very good session. Yeah,
Thank you, sir. Good night.
good night, bye bye.
Thank you.
Thank you.
Thank you.
You're welcome. Okay, so the lectures are at this is the YouTube channel, and the email ID is learnwithamitbansal at, my name is Amit Bansal, by the way. Yeah, so first is the YouTube channel where I upload the live sessions, the recording of live sessions, sorry, and then you can email me if you have any doubts. And if there are some good questions, we'll even discuss in class, because sometimes, see, I'm only focusing on gate questions, but sometimes it happens that net asks some very beautiful question, or just asks some beautiful questions, and then we should take up that. We are here to, yes, Darshan, sorry, learn with Amit Bansal is the channel name, correct? Okay. Okay, just hold on, Anuj, wait a second. Yes, this is the correct, this is the one. Okay, oh sorry. Yeah, okay. Sir, is there any significance of negative sign? No, as I told you, these are some nomenclatures. Like sometimes like you see that let's say if velocity has come negative, what does this mean? This means that it's in the opposite direction. It's that's why it's important to note the magnitude here, because it's I told you, it's a matter of notation. The magnitude is the thing of importance. A negative sign otherwise is not important, it's just notation. There's no specific consequence of a negative sign in this case. I should say it like this. Okay. I'll stay. If you have any doubts, you can ask me. I'll stay for like 5 or so minutes. Otherwise, you may leave. Negative sign in between delta t and yeah, that is important. That is very important. So what we are doing is that we are subtracting the time component with the space component. That's the space time interval we are talking about. Yes, so that negative sign is very important. In case of Cartesian coordinates, we add a book we can refer. Anuj, I'm sorry, I cannot tell you that which book, because as I told you, I did not refer any books for, especially for special theory of relativity, because just one second. Just one second. So the first, I do not know any books. First thing is that. Second thing is that the questions that are asked here are from a very how should I say, are from a very narrow perspective. A very few topics are touched upon in this exam, gate exam, as far as the books as far questions are concerned, right? So books may cover many concepts which are of importance if you are interested in that, or if you want to pursue future studies in that. That's important for you. But since this is a general class where I'm introducing the concepts and we are solving problems, I do not see any importance for this topic. For some topics, yes, it is required. I What I would say is that there are some previous, I forget the name of, there is some book which has the previous year question of, let's say, 5 years, 10 years. Net JRF book is there, I'm forgetting the name. There is some theory given in every book for that matter. Even H.C. Verma has some theory on special theory of relativity, the H.C. Verma for 11th and 12th class. Yeah.
No problem, sir.
So you can.
I have DJ Griffith, sir. In last chapter, there is a.
You're talking about H.C. Verma, right?
No, sir. DJ Griffith, they have also in electrodynamics.
Yes. Correct. Electrodynamics also will have these. They'll touch upon these subjects. The point is that see, you can approach it from different perspectives. You can approach it from the electrodynamics point of view, which Griffiths is doing. What H.C. Verma does is that it approaches from the classical mechanics point of view.
Yes, sir.
Right, so that's what I'm saying, because this special theory of relativity sits in between, because we're talking about light here. Light is an electromagnetic wave, we know that. Plus it so happens that this concept also talks about distances and whatnot, right? We are talking about all that we are talking about conversions. We'll talk about transformations in next class, right? That has some mathematical physics concept, and it falls in the, because special theory of relativity is nothing but an extension of classical mechanics, so to speak. What happens when you go to very high speeds, when you approach the speed of light? What happens to the motion? That's the basic question that we answer in special theory of relativity. So you can approach it from different angles. So that's what I'm saying. The way how you want to read it, it's up to you. I will be focused on how to approach the questions of special theory of relativity from a gate exam point of view.
So in gate, we didn't go for the electrodynamics relativity.
No, see, the thing is that it approaches from, see, I've forgotten, I read it once in Griffiths, but I've forgotten how they formulate it, right? Here in this, the formulation is pretty straightforward. That space-time interval, you equate them, you solve a equation, okay, and then you get the values, you get the x values of x prime in terms of x and t. We'll see in the next class, I'll do that, okay? When we do it from electromagnetic point of view, that's a different ball game, because electromagnetic, we usually express them in terms of waves, right? E to the power I kx minus omega t, if I remember correctly, right? If you're formulating through that perspective, that changes things, right? See,
okay. Thank you very much, sir.
Yeah, it's okay. Mandlik, why can't we add it? Okay, how should I say this? I do not have any specific answer, but it's formal. I'll look into this. I'll tell you in next class. But I've always taken it that as that it's just like something that we add, like x2 minus x1 whole square plus y2 minus y1 whole square. We do that. So I just took it like as it is on that. But I'll look into this, and I do not know the answer now. In the next class, I'll try to look up and answer you. Is that fine?
Okay.
Yeah. Okay. Thank you very much. Good night.